Hey everyone, thanks for joining. My name is Michael. I'm your host today, along with my colleague Ryan Wallner. We are going to get started with our office hours in about 1 minute. Just give another few folks a minute to join. Already have a bunch of you on the line, so thank you for joining. Just give me a minute, and we'll be back to get started. Thanks. All right, it's 1 minute after the hour, so let's go ahead and get started. Welcome to another Portworx office hours. If this is your first time joining us, welcome, thank you. If you've been here before, then great, thanks for coming back. We are going to, well, let me back up. So this isn't really kind of a webinar, so it's a little bit more interactive, really, it's an office hours. So what we're gonna do is, just to kind of get everybody on the same page and oriented, I'm gonna go through just kind of a short presentation overview of kind of how Portworx fits into this ecosystem around cloud native applications and otherwise we might call them modern applications. Some of the problems that we solve for customers and some of the customer use cases. Then Ryan, who looks like is also called Michael Franti in his window offering. He's the red t-shirted Michael, and I'm the one in stripes. Yeah. Ryan's going to walk through kind of some demos of some of the ways in which you can use Portworx to manage databases, which was one of our most common use cases for customers, some of the features and capabilities. And throughout all of that, we really like you to ask questions, because this is really, it's an office hours. It's a chance for you to, to ask questions, to ask us to dive deeper, ask inconvenient questions that, we have to answer because we're live, those kinds of things. So we want to keep it fun, I'm going to keep it interactive. And with that, I am going to share my screen. Hopefully everybody knows how to use the chat for questions, and there's also a questions panel. So feel free to do that. I'm going to share my screen now. Give me 1 second. Actually, hey Ryan, do you want to introduce yourself while I bring this up? I always have trouble with GoToWebinar.
Yeah, absolutely. So as Michael commented, my name is Ryan Wallner. I did fix it on GoToWebinar, so it does say my name now. I work on kind of all things solutions here and content at Portworx. And after Michael's session, what I'll do today is we're going to do sort of a live walkthrough of just kind of getting started deploying databases on Kubernetes with Portworx. So this webinar / series goes through a bunch of different live demos. Today's is going to be focused on sort of getting started with databases. We'll do some snapshots and show you how that works in Kubernetes. And we'll hand it back over to Michael.
Okay, great. I got my screen share going. So yeah, so that's, I mentioned at the beginning, if this is your first time, welcome. If it's your second time, so one of the things we want you to know is that, if you come to one, that's great, but come back next month, because we're going to be diving into a different area of the platform, which is why I like to keep this initial portion short. So if you saw it last time, grab a cup of coffee, come back in about 5 minutes. For those of you who are new, you can think about Portworx as a data services platform for Kubernetes. What that means is that we're really the enabler for you to run enterprise applications that require databases, queues, key value stores, AI pipelines, those types of applications as part of your Kubernetes deployment. We want every person in your organization to be able to benefit from the automation that you provide by running this Kubernetes platform. And so it's important that you can really run any app on any cloud, any infrastructure at every stage of the application lifecycle. You know, the reason you're here today is because data is really important to modern businesses, right? This is not new information. What is new is how digital leaders like you are putting together a cloud native stack in order to process that increase in data into business outcomes. We call that kind of value and insight. You know, this is built around containers and Kubernetes, but it also includes new peoples and processes like GitOps, DevOps. Now we have SREs that are part of our team, whereas that that really didn't exist except out of in a few small companies in Silicon Valley, even 5 years ago. And then we're building a lot with a lot of these open source data analytics engines, things like Cassandra and Cloudera and Kafka, TensorFlow, Elasticsearch, MongoDB, in addition to MySQL and PostgreSQL. Whereas before we were really building everything around one or a few small numbers of databases. As we look at this transition, what's really clear is that containers and Kubernetes are the driving force behind it, but they're not the only technologies that become a part of this movement. 451 does these really great industry surveys on a regular basis, and in their last one, they found that of new applications, 95% of them were being developed in containers. That certainly rings true with my experience talking to customers, that when they're building these new modern applications, they're doing containers from the beginning. And then we all know that Kubernetes is the leading container management platform. Now, where it gets a little bit tricky is when we start to say, okay, if I want to bring in these modern data services like Kafka and Elasticsearch, Cassandra, et cetera, to power my the insights that my business can drive, then how do I handle things like security and data management, backup and recovery, DR, high availability, performance? Kubernetes is a very extensible system, and it allows us to solve those issues, but it doesn't solve them for us. We have to make choices. One of the things Ryan will probably show when he does this demo is like an idea of a storage class. When you're a storage class, you have to make a choice about what storage infrastructure or what storage driver do you want to use. And a lot of storage systems that integrate with Kubernetes via CSI weren't designed from the ground up to handle the scale and dynamism of the Kubernetes environment, but also to provide the breadth or the range of services that it takes in order to operate an enterprise application. They might provide persistent storage, but they don't provide backup and recovery, or they might do HA, but they don't do container granular encryption. You really need all of those. Portworx, it won't surprise you at this point in the presentation, really delivers on that modern data experience for cloud native applications. So you can think about Portworx, providing the same levels of performance and reliability and data protection and security that you would be accustomed to for your traditional applications, but in a completely app-driven, automated, multi-cloud way. We take those standard enterprise requirements for data-rich services, and we bring them into the cloud native world. So it doesn't matter where you're operating that application, you get that same level of data experience. Portworx is a leader in its own right within the Kubernetes ecosystem. This is a report that was put out by GigaOM last year. They subsequently did a separate report just on Kubernetes data protection, and we were also a leader in that report. But Pure Storage is a leader as well. Is for practically an innumerable number of years running. I should actually know the exact stat. They have been a leader in the Gartner Magic Quadrant for primary storage. Really brings a lot of innovation to the storage market, and now we're combining those two. If you're not familiar with some of the customers that are running Portworx, we're really proud that it's some of the largest, most sophisticated Kubernetes users in the world. So no matter what you're dealing with, whether it's the scale, the dynamism, the environment, the types of applications, chances are we've seen it in one of our other customers, and we can bring that that experience to bear on your requirements. And then no matter what other part of the ecosystem you decide to work with, whatever Kubernetes schedule or whatever cloud, we have partnerships there that can help to make you successful. Our platform itself, and this is really what Ryan is going to demo, enables a number of things. First and foremost, it enables you to really run any application. And it doesn't matter if one developer wants Elasticsearch and another wants Kafka and a third wants RabbitMQ, to run all of those services on the same Kubernetes platform without being an operational expert in any of those services. Because microservices, there are just too many of these data services to be an operational expert in each. We can't hire an Elastic SRE and a Kafka SRE. We need to provide automation or use automation in order to operate these data services. We can do that in any Kubernetes distribution, in any cloud, any infrastructure. And when I say that, I mean, if you're running on bare metal servers, that's great. If you're running on top of Pure Storage, that's great. If you want to run on NetApp, that's great. Portworx is the way that you get the most out of that storage infrastructure for your Kubernetes environment. And then, of course, we're DevOps, we're all about Agile, we're all about low-hanging fruit, starting small, failing fast. You can bring Portworx in to your pilot projects, your test dev projects, and then we can carry you through all the way to global production. So what do we do within that macro environment? Well, we provide a number of data services for your applications. And these data services are consumable really as lines on a YAML file. So for instance, pxStore is our container granular software-defined storage layer. With pxStore, you can add high availability to your application just by adding a replication factor to your YAML file. DR is the same way. You can add a migration schedule to sync two different environments together. You can enable security within your application by adding a line to a YAML file. That's why we call these data services, because you have an application, you have a deployment in Kubernetes, but I want to add HA, I want to add security, I want to add backup. You can do all of that declaratively through your Kubernetes environment. A couple of details which I'm gonna skip over because I think I hit most of those on the last slide. At the end of the day, what Portworx provides is kind of a single management interface, our API, our PX Central, that enables you to add these various data services to your end user applications, regardless of the underlying infrastructure. And the upshot of that, what it enables is speed to market. You can simply get to market faster. T-Mobile is a great example of this. They actually reduced their app deployment times with Portworx from 6 months down to hours. It sounds too good to be true and unbelievable, but we recorded a webinar with Joe Searcy from T-Mobile that you can just Google T-Mobile webinar Portworx. You'll find it really, really great to hear from that architect about just the impact that had on their business. We enable agility. You can move and respond faster. Esri is a great example of this, of just kind of massive influx of traffic as part of COVID. Roblox is another great example of a customer that just had a massive spike in traffic. And because of Portworx, they were able to take that in stride and grow their business in a time of unprecedented change. One of the things that T-Mobile highlighted in their webinar was that not only do we move faster, but our apps, if there is a problem, we can solve it more quickly. So because they have more automation that they can bring, because they have basically Kubernetes in their back pocket and Portworx in their back pocket, their applications actually work better. And RBC is a great example of a financial services institution that was able to run more apps on OpenShift because of the increased reliability that Portworx enabled. And then finally, I call this a cherry on top, right? Cloud native and modern applications are all about getting more out of our data, moving faster, getting to market faster, but cost is not irrelevant, right? Even if we're not driving towards modern apps to save money, money is a finite resource. And Portworx, in addition to driving speed, agility, and reliability, also has a significant cost savings benefit. Nowadays, Business Innovation is a great example of that. We actually helped them cut their AWS storage bill by 60% by moving to Portworx. In the interest of time, I have a couple of case studies, but I feel like I just hit the highlights of those in my last slide, so I'm not going to talk through those. I will end on this slide and then turn it over to Ryan, which is to say, we're going to talk a lot about how Portworx is great for these modern cloud-native applications, but Pure, as a company, has great solutions and delivers that modern data experience, not just for these cloud-native applications, but for traditional applications as well. So just because we're investing in TensorFlow doesn't mean our Oracle goes away or SAP goes away. You need to manage both of them, and Pure is a great way to do that. So with that, I will turn it over to you, Ryan, for the demo. And just a reminder to folks, please do use the chat portion. As Ryan's going, I'll be manning that and answering as many questions as I can. And if I can't answer it, I'll kind of play moderator and throw them over to Ryan. So please, keep the chat full. And over to you, Ryan.
Cool, thank you. Going to share my screen. I think everyone can see it. So yeah, the first thing I really want to show everyone is how to get started, right? So this is an important piece of getting started with Portworx. If you head on over, let me make this a little bigger. If you head on over to central.portworx.com, this is where you go to get an account with Portworx, and I'm going to sign in with the user I always use. But once you sign up or log in using Google or GitHub, you definitely want to go check out your options to install Portworx. So a good prerequisite is to have a Kubernetes cluster. This page doesn't do that for you, but there are many good resources out there, and even cloud platforms like EKS and GKE that you can easily spin up a Kubernetes cluster. That's sort of a prereq for using this tool, because it will install either Portworx Enterprise or PX Backup or Essentials here, our free version, onto that Kubernetes cluster. What I'll be showing today is Portworx Enterprise. So if I wanted to go ahead and get started, I'd go ahead and select Portworx Enterprise and click Next. I'd select, I prefer to use the operator. It's sort of, Kubernetes operators are sort of the thing that are becoming sort of more widely used, and ours is great. So if you're testing, I recommend, or if you have a small cluster under 25 nodes, I recommend using the built-in key value store. So in this case, you don't really have to input much. Of course, you can choose your cloud or on-premise. If you're using cloud, in this case, I'll be showing a Portworx installation on AWS, and you can easily click AWS and select the size and type of disk you want Portworx to use in the back end, meaning Portworx kind of consumes this storage from the cloud or on-prem and will aggregate it across the nodes, making it available to your containers. Once you select that, typically auto discovering your network interfaces works really well, but if you have a specific network setup, definitely change that. And lastly, kind of select where you're going to be installing this. Note, if it's not listed here, select none. That just means you're using Kubernetes. OpenShift for PKS or something like EKS need a little bit extra when it comes to making sure Portworx runs appropriately. So if I was using EKS, I would finish there. And then once you have that, you get a few commands that you would copy. So I would copy this and apply it to my cluster, and then I copy this and apply it to my cluster. If you want more control over what's happening, you can absolutely take a look at what the spec actually looks like. And this is YAML, and you are going to be working with YAML a lot if you're working with Kubernetes. We'll even use some today. But this kind of specifies everything that's going to be installed. And the end game is when you actually run the installation, you will get a Kubernetes deployment of Portworx in the namespace that you desire. I'm using the kube system namespace. And as you can see here, Portworx will be installed and running. I set up this cluster a while ago, but the point being is that you will be able to get a Kubernetes cluster up and running using this tool, and just by kind of clicking around and copying and pasting into your Kubernetes environment. And once you do that, when you actually have access to our Pixie-Cuddle, which is the CLI tool, you should be able to get a status showing kind of the health of that cluster. Now, if you chose PX Enterprise from the menu I just showed, you will automatically get a trial enterprise license. So that's what this is depicting, but it should say operational, and it should be using the storage you provided, as well as kind of give you the nodes that are available in your cluster. Now, keep in mind, if you're installing Portworx Enterprise, you need at least 3 storage nodes, and that's to make sure that there's a quorum of nodes, and 3 is a good way to go. So 1 master and 3 nodes is a good kind of cluster to get started with. Okay, so Portworx is up and running. You use PX Central to get started, either with Essentials or with your enterprise license. And now you want to launch some applications. So Michael talked about storage class. That's the first thing I want to talk about. Storage class, like I said, if you are working with Kubernetes, you're going to be working with YAML. Let me make this a little bigger for everyone. This is a YAML file that defines a storage class. A storage class is a way for an admin or provider to kind of dictate what type of storage is going to be provisioned for containers out of this backend storage that Portworx has. So what this is really saying is you give it a generic name. Usually you want to provide some sort of detail here, if it's for engineering, or if it has 3 replicas, like in this case, it's, give it a name that means something. And you define what the storage class is going to be like. Now, our documentation around dynamic provisioning, there's a lot more detail around parameters you can use here. I'm using 3 that are appropriate for the use case that we're going to be going through, which is replication level of 3. So this gives us high availability of our data across 3 different failure domains in our cluster. Now, we have 3 nodes in our cluster, so our failure domain is going to be at the node level. Now, if we had, 9 nodes and 3 were in one availability zone and 3 more were in another availability zone, and so on, we could actually make sure that this is using failure domain of the AZ level. So keep in mind that 3 replicas just means that there's 3 copies of the data on your cluster, but it's spread across the failure domains, which can be defined by you or provided by the cloud, or just in this case, I have 3 nodes, there's 1 on each node. IO profiles are all about getting the right sort of IO kind of path and everything for the specific workload. So if I was using sort of a content management system or SQL database, there's different sort of profiles that we have that you can use. I'm going to be deploying a Postgres database. I think DB Remote is the best one that we have, which basically does some specific tooling for databases. And I also want to make sure that my priority IO is high, which means it just targets the fastest storage it can find. So this is a storage class. And in this case, our storage class, we want to go ahead and create it. So let's go ahead and create the storage class, pxRPL3. Now, if you use kubectl to get your storage classes, we now see this storage class. And now I have an application here, which is a web UI and a Postgres database. So this demo application has a storage class within it, but we're gonna not use that. We're gonna use the one we just created. And now for the PVC, within a application like Postgres, you would define a persistent volume claim. Now, if you're new to Kubernetes, this is a way for you to define the type of storage you want. In this case, I don't have much going on here, but what I do know is that this PX Replica 3 storage class is available to me. So I'm going to go ahead and use that one. I want to use it as a sort of one-to-one mapping to my container. So this is where access mode of read write once comes in. And I just know I'm going to be testing. So 10 gigabytes is enough storage for me. And that's where this persistent volume claim comes in. Now for Postgres in general, there's some configuration that I have in a config map. Things like username and password. And then the actual deployment, which defines Postgres in the apps v1 API, we're going to use the Postgres 10.1 image. Take note of the scheduler name here. I'm pretty sure this happens automatically now with Portworx data management, but Portworx has a Stork controller scheduler built into it, and that's really stands for, Stork stands for Storage Orchestrated for Kubernetes. And really what it does is it does things like make sure your PVC and pod sort of land in certain places, meaning that it will try to make sure your pod lands on the same node that Portworx has its data. That way you're using less network hops, better performance, those kind of things. So it's a pretty powerful tool. Definitely make sure to use that. I'm pretty sure it happens automatically these days. And then a service to access Postgres. Let's go ahead and deploy this. So again, kubectl create Postgres YAML. So you should see everything created here. I did this in the default namespace, so we should be able to get pods, and we see one Kubernetes Postgres pod coming up. Now, if you do a get PVC, you should see your volume bound based on our storage class. And so this means that Portworx has provisioned that volume, and it is being used for this Postgres database. Now, if you wanted to get a little more detail on that volume and you have access to PXYCtl, something you can do is list volumes, right? So Portworx allows you to administer and sort of see the volumes as an administrator here. And this PVC name is the same name that you just saw from kubectl. Now, it's not always the case that an end user creating PVCs would have access to PXYCtl, but for demo purposes, this is sort of what Portworx sees on the other side. And if you wanted specific information, you can do a volume inspect. I'm using the shorthand VI, but it means volume inspect. And there's a whole bunch of information here. And I think this is really cool because this kind of shows you how tied Portworx is with Kubernetes, right? So right now I'm seeing the volume on the Portworx backend, but I can see things like the actual device path. So this is the virtual volume that Portworx actually creates on the Linux host on the POSIX system. But at the same time, I see labels that are tied to Kubernetes. I see HA values of the backend volume. I see exactly where those pieces of data land, so on exactly which node. So you can see that it's on 102, 103, and 101. So I know that I have copies of my data on all three. And then I also can see, oh, wow, Portworx can see exactly what pod is consuming this volume. So the point being is that, Portworx is tightly integrated with Kubernetes, and you can do all sorts of things. I think we're getting towards the half hour, so I do want to stop here. But you can do all sorts of things like snapshot this volume to your local storage here, snapshot it to cloud, resize this volume. It's 10 gigabytes, but as Postgres is being used, you can resize it live, which is really a powerful thing. So I'm gonna stop there and make sure we have at least a few seconds for questions.
Yeah, thanks, Ryan. That's awesome. So we do have a couple of questions, which I've been kind of active in the chat. And so I will, I've already answered the question, but I'll read it out for everybody else's benefit. So first of all, this customer is talking about being in the retail space and operating in a private cloud environment. And they were asking if we had any case studies about that. So what I did is I pointed them to two webinars. One I mentioned earlier, which was our webinar with T-Mobile. So they're running on-prem. And so Portworx, you know, a lot of our customers who run on-prem really like us because we provide a cloud-like experience for their Kubernetes applications, even if they're running in an on-prem environment where, for instance, they don't have, you know, Amazon EBS-like service. And so that's a big use case. And you know, we also have lots of customers that are running in the cloud, and so you can do it both ways. So I pointed him to the T-Mobile webinar, as well as we did a webinar with Kroger on a similar use case. They actually are running in the cloud, but I think there are some interesting points there from just a retail perspective that the customer can probably get some benefit from. So thank you for that one. A follow-up question to that one was about how Portworx guarantees high availability if a storage node goes down, or a node of my Kubernetes cluster where say my Postgres pod or my MongoDB pod is running. And they said, do you do data replication? And I said, yes, that's exactly what it is. So, you know, Ryan mentioned the storage class, you choose your replication factor. We're gonna, you know, make a copy or two copies of that volume on some other host in the cluster. And then when the node goes down, if the node goes down, really, when, not if, right, it happens, we can tell Kubernetes, from what Ryan shared about Stork, where they should place that pod to have the closest, lowest latency access to that data. So glad that was understood. Now we've got a couple of new questions, actually a bunch. So let me just go through these.
You can read them out loud if you want.
Yeah, this one's a little bit long, so I'm trying to get the gist. Yes, it's a good question. We get this sometimes, and it's basically saying, okay, great, I get how you do HA, but we have our storage infrastructure is already doing that that data durability and data replication. You know, is there a way to take advantage of that to not kind of be doing it at multiple levels? Yes, there are, and ultimately, this would be a great conversation to have with one of our architects. So hopefully we can connect after the webinar with you, because there are a number of different ways to do it. I'll kind of give my take, and then Ryan, if you have, you know, anything to add, you know, feel free to jump in. So the first is, you know, in Ryan's screen right now, you've got the HA level set to 3. You can change that to 1, which means you're only going to have your initial volume. You're not going to have any copies of it. So if the node does go down, then you're relying on your storage system to make that node available. You know, and that's fine. Portworx can still, for instance, do container granular encryption of that volume. So our PX secure capabilities, we could still take a backup of that volume associated with all of the Kubernetes objects via PX backup. What you won't be able to do is have Stork tell Kubernetes where to place a replica, where there's a local copy of the volume, but you have a volume that's durable on your underlying storage system. So that's not a problem. The thing that I think is interesting about Kubernetes is a lot of customers, or some customers, start with where you're suggesting, but how you manage data at the storage array level and how your Kubernetes DevOps engineers or Kubernetes architects or Kubernetes application teams manage their application, there comes a point in your scale where these paths diverge, and you probably don't want to rely solely on hardware specific operational capabilities that are completely disconnected from the application layer. So for instance, a Cassandra database, right? I've got a Cassandra database that's running in a 10 node ring across my Kubernetes cluster. That's going to be 10 volumes, 10 separate volumes that make up my Kubernetes or my Cassandra database. If I only have hardware specific tools, it's really challenging to take an application consistent backup of Cassandra. And sometimes you can do it, but it's non-trivial. And when I say application consistent, I mean we're actually quiescing the Cassandra database to flush any pending writes down to disk, take our snapshot across those 10 nodes at the same time, open everything back up, and then run node tool repair in this case to kind of resync and rebalance everything. Additionally, if you can do that, then that's still only the data. You still have to think about all of the configuration, which is Ryan's been showing in terms of our deployments, our storage classes, and all that kind of stuff in order to bring Kubernetes, bring that application back up. And if you want your DevOps team to be able to handle their own failure and recovery scenarios without coming to a centralized infrastructure team, which you probably do want to do if you're running a large-scale e-commerce platform, you get into a little bit of a disconnect, and you end up optimizing, in my view, at the wrong level of the stack. None of this is to say you can't do it. I think it would bear kind of a deeper understanding of your requirements and kind of the best way to take advantage of the flexible nature of Portworx to fit into a number of different scenarios. But I also want to just kind of point out that in Kubernetes, when you have a multi-tenant system where you have even internal multi-tenant, large numbers of application developers running many different applications, where each application has its own specific requirements around performance and availability and security, relying on the hardware, which is disconnected from this Kubernetes deployment completely, becomes sometimes an operational challenge. Anything you would add there, Ryan?
No, you nailed it.
Okay, great. One time today. So thank you for that question, and I hope that makes sense. And I'm not trying to be prescriptive, but you know, at the least, maybe it's entertaining. So can Portworx enforce any international legal storage constraints automatically? I think this is a policy question. And I'll, you know, my lawyer just pinged me on my Slack to remind me that I'm not able to give legal advice on this particular call. I think maybe one of the ways we could talk about this, can you talk a little bit about policy in PX backup, Ryan, and some of the things that you can, like, you know, if you have to take a backup, you know, every night and store it for 7 years, how you could do that through a schedule within PX backup. And then Daniel, if you want to reach us and talk about like some of your specific concerns, if that's like encryption or what policy you're specifically talking about, we can talk about whether or not Portworx can do it.
Yeah, I mean, constraints and policy can mean a lot of things. So Portworx in general, as we were showing today, you can define basically storage classes that use encryption policies and things like that, schedules that are based on policy for how often and where that those volumes are either captured or moved or encrypted. We do sort of allow you to create that type of policy at the Portworx level. In terms of constraints, we do allow you to sort of constrain where applications can access data, meaning that if you needed Portworx to only allow data to land on specific nodes, meaning that, you know, it had to be on-prem or it had to be on a specific, you know, chassis, that kind of thing. There are ways to do that with volume placement strategies. You can look at our documentation for volume placement strategies. And for backup policies, as Michael was talking about, this allows you to do a similar method to set up a policy within PX Backup that allows you to define, again, how often and where data is sort of backed up and stored long term. So again, we can you can dive into more specifics. It sounds like you have a very specific question, but those are the options you have today.
Okay, awesome. Thanks, Ryan. And another one for you. If I use NAS, where do I configure the device path?
Yeah, and there was one right before this around, yes, the recording will be available. Yeah, NAS, I did send this, I think, to you directly, but so everyone can hear it. Portworx does not support NAS as a back end, meaning that when I showed you how to configure the storage here in this section, there's my back button. There's no ability for you to use NAS here. Today, Portworx supports local or storage area network or cloud-based block device storage to be a backing store. Now, Portworx does provide the ability to create NFS v4 shared volume, so you can basically have the equivalent of a NFS share to your containers, but Portworx has to create that shared volume, and that's just using a shared true flag on your storage class. But today we don't support NAS in the backend.
Okay, great. Next question, what's the best way to scale, actually in this one, what's the recommended way to add or expand disks in a storage pool? Should we put the nodes in maintenance state or just execute the command for expanding the storage pools?
Yeah, I believe in the past, older versions of Portworx did need maintenance mode, but this document here, if you go to Portworx installed with Kubernetes storage operations, create PVCs, expand storage pool, there are various ways you can do this. So we allow you to expand your storage pool automatically with PX Autopilot. I will be showing that I think next month's demo, so stay tuned. If you needed to do it manually, which I think is sort of the target of this question, you can add drives to your storage cluster, or just resize it. And I believe I believe this command does not need maintenance mode any longer, so you can just expand it using the resize. And then this 4 is basically the storage pool. Now, I showed you here in the status command, this storage pool is 0. So I only have one storage pool. So in my case, if I wanted to re-expand it, and if I had more space, it would be 0 instead of 4.
Okay, awesome. And this is a similar related question, what's the best way to scale storage while keeping the compute nodes fixed in a shared nothing architecture?
Yeah, so I think we sort of answered the few different ways you can do that here. So you can add the best way would be to add drives, right? So if you had to add, say, an attached LUN or cloud device to that compute node, so if you didn't want to add compute nodes and scale horizontally, you could add a device and basically add this drive. And what happens when you add a drive is we'll also rebalance your pools. So meaning that you have all this extra space, all your replication has used the old pools, now needs to rebalance where all those replicas land so you could take advantage of the full amount of storage. So that's definitely one way to do it if you didn't want to expand your nodes. And then the other option is if you're using cloud storage that supports resizing of the actual backend devices, meaning you didn't want to add a device, you didn't want to add a compute node, you can expand the device that exists and then auto take advantage of that size as we showed before, which is sort of what this is doing. You expand the pool given the backend cloud device has been expanded.
Great. So another similar, lots of, I love it because these questions are all about like, okay, how do I actually do this stuff in production? Not kind of like the happy path for day one, like what happens when this thing starts to grow. So can we use autopilot for some other automation besides expanding PVC, expanding storage pool, and rebalance of storage pool? One of the other things you can use for it is kind of Git integration. So for those capabilities, so it's it still ultimately is the policy that you want to implement, but we also have a way to integrate that with your GitOps system. And it's also extensible. So I would love to know kind of what you want to do with it. It's possible that that's already on our roadmap, or we've already have a customer who is kind of using it that way. So maybe you can you give us some more detail in the chat here, and we can answer it, or we can get you in touch with someone on our team. So thank you for that. For non-sensitive data, can Portworx backups go to Amazon S3? Yes, you can. To be frank, you can also put sensitive backups in Amazon S3 because we can do encryption and things like that. That's not a recommendation. I'm just saying that we can go to any S3 compatible object store that's consistent with your view of where your data needs to be located, whether it's on-prem or the cloud. And I'll extend this to say Google object storage as well as Azure object storage are also permissible backends. We have customers that are doing it on-prem to a FlashBlade. People are running MinIO, Scality, any object store that supports the S3 API, you can use as a backend. Yeah, so this question is, I want to run an NFS volume in containers, specifically NSV4. In NFS-v4 to containers, can you share documentation on how to do that? Do you want to pull up shared volumes, Ryan?
Yes, absolutely. So we talked about using a storage class before, and I showed this in the demo. You only need to add one flag, shared v4 equals true, and then you would use this storage class, and it would provide you a NFS v4 volume instead of a block-based volume. So I will share this link in the chat as well.
Okay, that was easy. Can we test the DR functionality with the enterprise trial license? I think so. That's a good question. Why don't you? I think the answer is yes. Why don't we confirm that by just chatting over email, Philippe? So we'll follow up with you after the webinar. In fact, let me just make a note to do that.
I think you can definitely test migrations, but DR might be different. But yeah, follow up with us.
You can test it before you buy it. That's not a problem. What we may have to do is just enable it for you versus it being able to. You can just do it self-service. So I'll check on that. I just wrote a note to follow up. Are you planning any special integrations with Pure Storage? Yeah, so lots of things on the roadmap. Basically we want to, extend. So Portworx, for instance, can provision EBS drives in the cloud, right? So if you deploy your Kubernetes deployment and your storage class specifies that you want a 10 gigabyte volume, if there is no EBS volume on an EC2 instance, there is no storage. We'll actually provision the underlying block device, attach it to the node, and then provision the virtual volume on top. We want to extend that into FlashArray. So that's one example. Ryan's been working on some integrations around data protection with FlashBlade, and we're working on a tighter integration there. Portworx is already available now in the Pure One services catalog, so we're working on that. So yeah, there's lots of exciting things that are coming as now that we're part of Pure Storage, and we can have tighter integration with the other Pure product teams. But what will remain always the case is that Portworx can run in any environment. So, if you're, we love Pure Storage, but if you're running on NetApp, then best experience you're going to get for your NetApp storage with Kubernetes is going to be with Portworx. But we will continue to have more and more kind of deeper integrations into the Pure ecosystem of products as well. Okay, I think we got to the bottom of the list. So we still have a few minutes. If anybody wants to pop something else in, happy to keep going.
Yeah, in the meantime, I'm gonna keep going if you want. Now that we've gotten through most of our questions, I'll kind of finish up demoing here. Obviously, ask more questions if you want to. Yeah, so where do we get to? We have a volume. Let's see, kubectl get PVCs. So we have a volume. Now let's just take a look at what a snapshot would look like. So Portworx does enable you to take snapshots. In this case, it's just a snapshot designation, a name, the namespace, and the target Postgres volume, which I believe is Postgres data, and so that matches up here. You can directly snapshot it using PXYCtl, but the benefit is, you can use kubectl for almost anything as an end user to manipulate Portworx and the volumes. So now what we can do is get the volume snapshots and see that there's a volume snapshot here. Now the nice thing is, as we did before, we can head to our actual Portworx node, and we can add a volume list -s, which shows us the snapshots. And here you can see specifically the snapshot designated by snapshot dash, and then the ID of that volume. And notice it's detached because snapshots are obviously just not used unless you create a clone from that snapshot. So again, that's how a snapshot will become available. And then if we wanted to use that snapshot, we could restore that snapshot. I think I have an example here, Postgres restore YAML. So in this case, we would create a persistent volume claim. Now keep in mind, we're going to target the Postgres snapshot we just took. And note that the storage class is the pointing at stork snapshot SC. And this is important because stork is the snapshot class that's going to enable you to clone that volume automatically. And then what we'll do is place it back into a deployment and launch it. So let's see here. I think I lost my... Can you still hear me, Michael? Oh, I lost my connection.
Yeah, I can still hear you.
Sorry, I lost my connection momentarily there. Seems like I'm okay now. So again, Postgres restore, and then that clone is created. So now if I do a kubectl get PVC once again, now I have the snapshot clone, and I think I should have another pod here that's coming up, and that's just the config map is being used by the existing one. But if we look at our Sage node 1.1, it looks like my environment's a little bit laggy, and this is the live demo experience. All right, looks like I'm going, my connection's coming in and out. So I'll try it one more time. Okay, let's try this one more time. I don't know if I'm going in and out for you, Michael, but I seem to be losing my connection.
I can hear you. Well, let's and I can see your screen. I don't know.
Okay.
I can see you typing and everything. Well, we have a couple more questions.
Okay, yeah.
So since we're having issues. This question is this quick start guide to setting up Portworx alerts in Prometheus. Do you want to pull that documentation up? How to configure Prometheus?
Sure. So the other thing is when you're going through creating your cluster here, as you go through this this configuration, there is a advanced setting here where you can enable monitoring. And so this will actually give you everything you need to enable that monitoring. So this will enable the monitoring stack for you if you just select that. But this is the documentation, I believe. No, we want Prometheus. There we go. So we do have integrations with both Prometheus and Grafana. But I recommend definitely going through the PX Central way. So if you search, so it's install with other, operate and maintain, monitoring, and Prometheus. If you search Prometheus in docs.portworx.com, you will get there. But I would recommend definitely using the enable monitoring setting here. The other thing you can do is down here in the main installation, we have a what we call PX monitoring sort of stack, and so you can set up our PX metrics and monitoring stack with Helm. It does allow you to sort of configure the license server and things like that, but you don't have to, right? So if you don't want license server, don't click it. So this is where you would connect monitoring to.
Great. Looks like 2 more questions. These will probably be our last ones. Maybe we'll do like at a bar, last call. So get your questions in now. We'll try to get as many of them as we can. So this one is, can you please share some performance numbers? I understand it depends on the underlying storage infrastructure. Do we know the overhead introduced by Portworx using the storage compared to the same storage used directly? Yeah, great question. So Ryan, you want to pull up FIO testing on the docs?
Yeah.
So as a starting point, you can go to a docs page. We have FIO testing. So the way that we kind of a non-biased way of measuring storage performance is with a library called FIO. So we have kind of the methodology for running the tests, and then the results on a variety of workloads. And then we've also have kind of a bench, if you want to run the benchmarks yourself, which you probably will, and we would recommend, how to actually do that. In general, we see around 3%. This person also mentioned that, Portworx is in the data path, and that is true. So we see about 3% overhead. And that's the name of that tune. So if you have any other questions about the FIOS testing, feel free to reach out to us. We should have a conversation, help you figure out how you can get the performance that you want. Actually, while you're there, Ryan, if you want to also bring up performance tuning, if you just put that into the search, there's another page where kind of, if you don't like the numbers that you're getting, how you can use various IO profiles, as well as storage classes within Portworx to tune for your particular workload. All right, got a few more. Last round that worked. Is Prometheus Monitor available with the free trial or only the enterprise trial? Yeah, the enterprise trial includes everything. I'll get you the specific answer on DR. That's the one that I don't know about, but Prometheus monitoring, that's just part and parcel of the platform. So DR is an optional service. And that's why I'm not quite sure if you automatically get it licensed or you have to come to us for that. But Prometheus monitoring, that's just included. The free version, the freemium. So monitoring with PX Essentials, I believe it is.
Yeah.
You're nodding, Ryan. Yeah.
Yeah, it is. We use Prometheus, Grafana, open source tools, so those come right for you.
Yeah, and if it's not clear to everybody else listening, Portworx Essentials is our freemium offering. So you can run basically the things that Ryan showed in the demo today, free forever. You're limited by the number of nodes that can be in your Kubernetes cluster, ultimately how much storage you can have. But in terms of the replication and the snapshots and the monitoring, you can do all of that with Portworx Essentials, subject to some of the limits that are listed out on our public website. I mean, it's a great way to just get started, either with your testing or with a smaller project that you need the reliability, but ultimately don't want to it's just 5 nodes, so why not use the free thing? The other piece is we offer pay-as-you-go pricing. So let's say you have more than 5 nodes and you're not yet at 1,000. Where do you do? And you're growing quickly, or you think that you're going to go quickly, but you're not there yet. You can do our pay-as-you-go model, where you basically license what you need and you just true up as you grow over time, versus making an upfront large commitment. And all of the pricing for that is publicly transparent on our website. So you can kind of have all the information you need to make a decision.
Yeah, and there's marketplace offerings too, which offer you sort of a similar pay as you go, but using something like AWS.
Yep, exactly. Yeah, check us out on the AWS Marketplace, IBM Marketplace, Google Cloud. Yeah, good point. Okay, folks. Well, we are at the top of the hour. Thank you so much for joining us. We'll send the recording out, and some really good questions. I think that bear some follow-up discussion. So we'll reach out as well. Try to schedule some time with you and really dive into your specific use case and questions. Thanks again. Until next time. Cheers. Bye.
Take care.